All right, today we're going to do something a little wild. We're going to completely tear down our understanding of the universe and then rebuild it right from scratch. We're diving into a radical new way of thinking about physics that says reality as you and I know it, well, it might just be an illusion. So buckle up, because this idea changes literally everything. So I want to kick things off with a question. It's a question that might sound kind of absurd at first, but trust me, it is the key that unlocks this entire concept. What if spacetime, the very fabric of reality, the stage where everything in the universe plays out, what if it isn't fundamental at all? What if it's just an illusion? And look, this isn't just some philosophical what-if game. This idea comes directly from the source material we're digging into today. The claim is that our reality is actually a simplified model. Think of it like a super compressed file that's built from something way, way more basic: pure interaction.
So why on earth would anyone even come up with an idea this out there? Well, it's because our current picture of reality, it's got some serious cracks in its foundation. For more than 100 years, physics has been ruled by two incredible theories that, unfortunately, can't stand each other.
On one side, you've got Einstein's general relativity. It's our perfect guide to the big stuff: planets, stars, galaxies, the whole cosmic dance. And on the other side, we've got quantum mechanics, our equally perfect but totally bizarre guide to the tiny world of atoms and particles. The problem? They hate each other. Seriously, their math, their core ideas, they just fundamentally contradict one another. And this isn't some small, nerdy puzzle. It's a giant, flashing neon sign telling us we are missing something really, really profound about how reality actually works.
Okay, so to try and solve this, a new framework called HAOS has been proposed. Now, HAOS isn't just another theory trying to compete with the others. A better way to think of it is like a super strict quality control test, a set of rules that any theory has to pass before we can even begin to call it fundamental.
And this test has one rule that is absolutely non-negotiable. The number one rule is you are forbidden from starting with spacetime. Period. The framework calls this a representation primitive failure, which is a fancy way of saying that assuming spacetime exists from the get-go, well, that's basically the original sin of modern physics.
Okay, so now we have our new super tough quality control test. So let's do it. Let's run our most cherished theories through it. How do they actually stack up when we take away their favorite starting point, that spacetime safety blanket? Now, before we run the test, we need to get our heads around one really important concept: representational collapse, which we'll just call pi. And the analogy here is perfect. Imagine you have a complex 3D object, right? The 2D shadow it casts on the wall, that shadow is a real, useful representation of the object, but it's obviously not the object itself. This new framework argues that our biggest theories, like spacetime, are exactly like that shadow. They are a collapse of a much bigger, higher dimensional reality of pure interaction down into a simple model we can actually use. So, when we actually run our theories through this HAOS test, they all fail. At least, they fail as foundations. Einstein's relativity? It's out on the first rule, because it's built entirely on spacetime. The many worlds idea? Fails because it treats every possible outcome as equally real, without filtering for the ones that are actually stable. And the good old Copenhagen interpretation? It fails because it just says the collapse happens. It describes the shadow beautifully, but never ever explains the object that's casting it. So these theories aren't wrong, but they are inadmissible as a starting point. They're just shadows, not the light source.
All right, so we've basically cleared the rubble. We've shown that our old foundations are kind of built on sand. So now for the really exciting part. We get to rebuild our entire picture of reality from one single HAOS-approved idea: interaction. Here's the 4-step recipe for building a universe. Step 1, you start only with interaction. Nothing else is allowed. Step 2, you imagine every possible history, every single sequence of interactions that could ever possibly happen. Step 3, and this is the magic part, you filter them. You toss out any history that's just not stable or coherent. And finally, step 4, you take all those good, viable histories that are left and you compress them down into a simplified model, a representation, a shadow that saves their most important shared patterns.
And this is where it all just clicks together, and it's just mind-blowing. It turns out quantum mechanics and spacetime are just two different ways of compressing the data.
They are two different shadows cast by the exact same underlying reality of pure interaction. The quantum shadow preserves things like phase and spooky action at a distance. The space-time shadow preserves different stuff, like cause and effect and locality. They're not in conflict. They're just different, totally valid ways of looking at the same deep structure.
Now, if that's true, the consequences are, well, they're profound. It means that the things we think of as the most basic building blocks of reality, things like time and causality, they aren't fundamental at all. They are just features of the particular shadow we happen to be looking at.
So let's just get this crystal clear. Time is not a river we're all floating down. It is not a fourth dimension. It's not some cosmic clock that's ticking for everyone. All of that, that's an illusion. It's a feature created by one specific representation of reality.
So if time isn't a river, what is it? Well, at the most fundamental level, it's just the ordering of stable interactions. It's the rules about what can happen after what. It is a consequence of the structure. It's not the container that holds the structure. Let me say that again. Time doesn't make interactions happen. Interactions create the very structure that we perceive as time.
And yep, the same exact thing goes for causality. The whole idea of cause and effect is not some ironclad universal law that's governing everything from on high. It sure feels like it is, but that's just an artifact of our point of view.
So what causality really is a set of rules that's specific to the representation you're using. The space-time shadow? Yeah, it has super strict rules about cause and effect. But the quantum shadow? Its rules are, well, they're different. They're looser. There's no single universal law of causality. It all depends on which shadow you happen to be looking at. And this all brings us to the grand finale, the big takeaway. This whole idea completely reframes the biggest quest in modern physics for the last 100 years. And it tells us we've pretty much been chasing a ghost.
Here's the problem. For a century, we've been trying to unify two different shadows. I mean, just think about that for a second. You can't take a 2D shadow of a cube from the side and a 2D shadow from the top and then merge them together into one unified shadow. It's a completely nonsensical goal. To understand how they're related, you have to stop staring at the shadows and start looking at the 3D object that's casting them.
And this just nails the point home. Quantum theory and space-time, they're just different families of representation. They save different kinds of information from that fundamental level of pure interaction. And one is not more real or more fundamental than the other. So trying to unify them is kind of like trying to unify a map of the subway with a satellite photo of a city. The goal isn't to merge them. The goal is to understand the city that they both represent in their own different ways. And this is where we have to leave it. If everything we experience, space-time, time, causality, is just one possible representation, just one shadow cast from an infinite sea of pure interaction, well, that leaves us with a truly staggering thought. What other representations are out there? What other stable realities with completely different rules could exist? What else are we just not seeing because we can't learn how to look past our own shadow? It really makes you wonder, doesn't it?